Dear students, welcome to Environmental Process Systems Tutorial 8. Question 1. Write the general mass balance equation for A. CSTR and B. batch reactor. To derive the general mass balance equation for a CSTR, you always have to start with the basic mass balance equation. Now in this case, you can assume that the system is at steady state for a CSTR system, and therefore you can then put your dCA dt to be equals to 0. On top of that, you also know that the residence time tau is equals to V over Q. Therefore, the general mass balance for your CSTR is equals to 0, 1 over tau Ca naught minus 1 over tau Ca negative Ra. So if your reaction rate is a first order, then your equation here will then becomes Kca. So similarly for the batch reactor, you have to first start with the basic mass balance equation. And then, because for the batch reactor, there are no inlet flow rate and no outlet flow rate, therefore, you can then derive your basic mass balance equation for a batch reactor to be equals to dCA over dt equals to plus minus your reaction rate of A. So in this case, if your reaction rate of A is a first order, this term will then becomes Kca. Question 2. In a batch reactor, species A undergoes an elementary first order irreversible reactions to form product B. The K value is given as 0.045 per second, and the conversion of species A is 70%. How long did the reactions occur for? So similarly, you have to start with basic mass balance equation. Now in this case, because it's a first order reaction, so therefore your Ra will be equals to negative Kca. Now input all the values that you know into this equation. You have dCA dt equals to negative 0.045 Ca. Now you have to solve for integration. So you integrate from Ca naught to Ca, and then you can bring your Ca down to the equation. So you have 1 over Ca dCa. Bring your dt over the equal sign. So you have negative 0.045. Integrating from 0 to time t dt. Now with this, you can now solve. So integrating 1 over Ca will give you ln Ca, and you are integrating this from Ca naught to Ca is equals to negative 0.045, and you have 1 T0. So therefore, ln Ca, you will get ln Ca minus ln Ca naught. So essentially, this thing will becomes ln Ca divided by Ca naught, because ln Ca minus ln Ca naught, you can combine them, is equals to negative 0.045 T. Now, it is mentioned that the conversion is 70%. It means that your Xa, which is essentially equals to Ca naught minus Ca divided by Ca naught, is equals to 0.7. So if you were to calculate them, your Ca will be equals to 0.3 Ca naught. So you have ln, convert your Ca to become Ca naught, divided by Ca naught equals to negative 0.045 T. Now with this, you can then solve the equation easily because Ca naught and Ca naught can be cancelled out. So therefore, you will get a time to be equals to 26.75 seconds. Question 3. A reaction tank decomposes pollutant A via a second order elementary reactions with a K value of 0.004 liter per milligram dot seconds. So since it's given that it's a second order elementary reaction, you will know that your Ra term will be equals to negative KCa square. If the initial concentrations of pollutant air into the tank is 200 milligrams per liter and the exiting concentrations of the pollutant is 35 milligrams per liter, they want you to find the volume of the reaction tank, assuming that the inflow and outflow of the water into the tank is 95 liter per minute. Now, the first step to doing this question is you have to first guess which type of reactor are they referring to. Now, you can see that they have stated the flow rate. So, therefore, it will definitely not be a batch reactor. So, technically speaking, you can guess that this will be a CSTR reactor. So with that, you can then now derive the basic mass balance equation for your CSTR reactor. So for your basic mass balance equation, you have to assume that the system is at steady state. And when you assume that the system is at steady state, you can then put your dCA over dt to be equals to 0. With that, you can then now write in the rest of the equation. So you have 0 equals to, the flow rate in this case is given as 95 liter per minute, multiplied by initial concentrations 200 milligram per liter. Then the outlet flow rate is also given as 95 liter per minute, which is similar. The outlet concentration is given as 35 milligram per liter. Now then, you will have your negative because it's a second order reaction, so KCa square. K value is given as 0.004 liter per milligrams tot seconds, multiplied by the concentrations out from the system, so it's 35 milligram per liter, but don't forget you need to square this value, then you multiply by the volume. Remember, we say you have to check and make sure that each term in this equation are having the same units. So in this case, this liter and liter cancel, you can get milligram per minute. The second term, similar, milligram per minute. But the third term, you realize that if you were to cancel one of the milligram with this, one of the liter with this, because there's a square here, right? So you can cancel, but it's per second instead of per minute. So do not forget that you have to convert them. So therefore, you have to convert this to become per minute. So 1 minute is 60 seconds. So then, if you convert everything properly, you will then get an answer of the volume to be 53.3 liter. So we have come to the end of tutorial 8. Thank you for watching.